My name is Alupo Samuel Kayode. I want to say a very big welcome to this very channel. I will be taking you through the practical steps in mathematics on how to solve every mathematical questions. All right, thank you. Today, I will be taking you on an introduction to indices and logarithm. Indices and log. On this very lesson, I'll be taking you through a numerical process and we'll be considering logarithm and indices. Firstly, I want you to know that indices and logarithm has to do with base and power. Base and power. This is referred to as base and this is as power. You must have a knowledge of this, that it has to do with the base and power. Even if it is log, if you have log of any number, there must be actually a base. Maybe let's say x and that's of y. Here, this is the x here is the base. So you must have an understanding of that. And this is the log and indices are just replica of one another. Then another thing you must know is that your base must not be equals to a 0. Base must not be equals to a 0. It simply means that every of your base must be a positive integer. Must be a positive integer. Laws of indices. The first rule, like I said, every of your base must be a positive integer. Let's consider that one as the first rule, which simply means that if you have base of power n, your base here must not be equals to a 0. But your power can be 0. There is no problem on that. Your power can be 0. That's number one. Number two, if you have your power as equals to 0, it simply means that if you have an indices of base A and power 0, law of indices says that this is equals to 1. It means that if you have any base that is equals to 0, so simply let's take an example. An example, if you have 2 raised to power is 0, this law says that your 2 raised to power is 0 equals to 1. So come to think of it, what about if you have 10 raised to power is 0? What does it mean? It simply also means 1. That is another rule. Another rule says that if you have 2 indices of the same base, if you have 2 indices of the same base of different power, all you need to do is add up the power. So which means that if you have a raised to power n multiplied by a raised to power y, let's make this x so that we can give it a number alphabetical order. A raised to power x and a raised to power y. Note something, the base are the same thing. If the base is the same thing, law of indices says that all you need to take one of the base and add up the power. It means that a is equals to, this is equals to a raised to power x plus y. Note something, the base must be the same thing. So that means that you cannot have a raised to power x multiplied by b raised to power x and you think this cannot be a raised to power x plus, let's make this one y, plus y, because y, the base are not the same thing. Note, this is always the base and that is the power. So this cannot be the same thing. All right, so let's take an example. If you have 2 raised to power 3 multiplied by 2 raised to power 5 According to this very law, it means that this is 2 raised to power 3 plus 5, which is the same thing as 2 raised to power 8. Okay, let's break this down to confirm if this law is actually true. 2 raised to power 3 simply means 2 multiplied by 2 multiplied by 2, right? Multiply by 2 raised to power this to 5 places, 2, 3, 4, 5. So it's the same thing as this. So if you multiply this, 2 multiply by 2 multiply by 2, then multiply by 2 multiply by 2. So if you count all this together, you discover that it is the same thing. 1, 2, 3, 4, 5, 6, 7, 8. So that proves the law, right? So let's take another example. What if you have 5 raised to power 7 multiplied by 5 raised to power 8? Note something. The base must be the same thing. Please take note of that. It's equals to 5 raised to power 7 plus 8, which simply means that this is 5 raised to power 15. So let's take another law. Let's take another law. So another law says that if you have a raised to power x divided by a raised to power y, the law of indices says that this very law says that this is equals to the same thing as a raised to power x minus y. Don't forget, the base must be the same thing. The base must be the same thing. So let's take an example. Let's take an example. So if you have 2 raised to power 5 divided by 2 raised to power 3, so this is the same thing as 2 raised to power 5 minus 3. So this is the same thing as 2 raised to power 2. That is taken. So let's consider another one. Let's consider another law. Another law says that if you have base, the same base, but of different power in the bracket. Remember BODMAS? Remember BODMAS? Which is bracket of division, multiplication, addition, and subtraction. So that means if you have this kind of thing, a raised to power n and m. So this is the same thing as a raised to power n m, because this is bracket, and this bracket simply means that multiplication. So this is the same thing. This is the same thing as a raised to power n minus m, because this bracket simply means multiplication. But this time around, you are multiplying the powers. You are multiplying the power. So let's take an example. If you have 2 raised to power 3 into power 5, you see this is different from the first, from this very law. So it's the same thing as 2 raised to power 3 multiplied by 5. This is the same thing as 2 raised to power 15. What about if you have this, instead of you having it as this, if you have it as 2 raised to power n, you can see it's the same thing. So it can either be mn, and also it can also be n. All right. So let's take another law. Let's take another law. Law 6. If you have base like this, of this multiply of n, a raised to power m. So what do you do? Now, note, the base must be the same thing. The base must be the same thing. You can see this is division. It's the same thing as you having it as this. So don't get confused. This is the same thing as this, because this is division. This is division. So therefore, if you translate this, this is a raised to power n divided by a raised to power m. So this is the same thing as this. So what do you have? You have it as a raised to power n minus n. So please take note of that. So let's take some other. Let's take some other one. If you have a negative power, what do you do to that? A raised to power minus n. If you have this as a negative, because you can have your power as negative. That means it can also be a negative integer. So what you do is simple. This law says that you have it as 1 all over a. That's an inverse. That simply means an inverse. A raised to power n. Let's take an example of that. So this simply means that, example, if you have 2 raised to power minus 3, it simply means 1 all over 2 raised to power 3. 1 all over 2 raised to power 3. Let's take another law. If you have this law, x raised to power a all over b, x raised to power a all over b, it simply means the bit root of this very base. The bit root of this base, which simply means that bit root of this very a into the power, the power of a for this very base. It simply means this raised to power a. Let me take that. If you have this very equation, equation x a all over b raised to power a all over b, it simply means the law of indices says that take the numerator, because in fraction, you remember in fraction you have a all over b. This is the numerator and this is the denominator. So the law says take the denominator and make it the root of that very of this very question, and take the numerator into the power. So let's take an example. If I have 2 raised to power, let's say I have 8 raised to power 1 all over 3. 8 raised to power 1 all over 3. 8 raised to power 1 over 3. This is the same thing as the cube root of 8, but the 8 is to the power of 1, because what you have here, so we have to express this like this. We have to express this very question like this. So that means the cube root of 8 is 2. So that means 2, because this is the same thing as raised to power 1. So the answer here is 2, because what you have here is still the same thing as cube root of 8 to 1 is the same thing as 8. So cube root of 8 is 2. So let's take another law. Okay. I think basically we've covered most of the laws. I'm looking at if we can take another one. But basically, this is most of what you have all around. This is most of what you always have. So let's take a question. Let's take a question from past questions of WAEC. This is 2021. This is 2021 WAEC mathematics objective question. And the question, let's take some questions. And the question is 2 raised to power square root of 2x plus 1 is 32 equals to 32. So how do you approach this? Let's look at how we can solve this. Simply, what we're looking for here is the x. This is 2 raised to power this is 32. Can we convert this to the same base? Can we convert this and this to the same base? So what you do, you say this is 2 raised to power 2x plus 1 equals to, can we convert this 32 to become the same base with this very one? Yes, we can, because this is the same thing as 2 raised to power 5. Let's prove that. 32, we say 2 raised to power 5, okay? Multiply by 2, multiply by 2, multiply by 2, multiply by 2, that's 5. 1, 2, 3, 4, 5. All right, 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 2, that's 32. So that means we're right with this. So you can see we've converted this very equation here to be of the same base with this. So what we do, if it is of the same base, then we can cancel this. That means we're actually treating the powers now. So what you do, you just, okay, this is square root of 2x plus 1 equals to 5. So now this is of the same school. This is square root. This is not square root. And actually what we're looking for here is x. So what we do now is that we say, okay, let's multiply both sides by the square of this, because we actually want to take off this very square root. So we now say, okay, multiply both sides by the square. Okay, let's say square both sides. That's what I mean. Sorry. Square both sides. Square both sides. So if you square both sides, that means you have 2x plus 1, the square root, square both sides equals to 5 squared. So if you do that, this is what you have. If you do that, that means this square will cancel this, because if you change this one into bracket, this is all we have as the same as 2 plus 1 all over 2. You remember from here, from this very law, the law 8. So both sides 5 raised to power 2. Now if you come to law 5 here, remember, if you come to law 5 here, that means the same thing. So if you have n, m is the same thing as a and m. So if we apply this to this, that means you have your 2x plus 1. This is the same thing as a half multiplied by 2 from here. Equals to 5 raised to power 2. So 2 can cancel this 2. That means you're left with 2x plus 1 equals to 5 squared, means 25. So all you have to do, collect the like terms. So that means you have 2x equals to, let me write the procedure. Subtract 1 from both sides. So that means you have 2x plus 1 minus 1 equals to 25 minus 1. So you have 2x, because plus 1 minus 1 is the same thing, is equals to 0. Okay, simply put, you have 1 naira with you, and you actually owing someone 1 naira, you will actually want to pay back. So that means this is 1. You have 1, and if you pay back, you have nothing left with you. So that is why this equals to is 0. So this is equals to 24. So now divide. Now one thing I quickly need to jump for you to understand is that this here is a variable and this is the coefficient, because most times students don't understand when they say, okay, what is the coefficient of this? So note this. This is actually outside this very lesson, but quickly I need to tell you before we get there. So if you have 2x and they ask you to identify which one is the variable, this very x here is the variable, and the number you have before the very alphabet is called the coefficient. The coefficient. So when we get there, I'll explain more of what is variable and that of the coefficient. But you just know that the letter you have is the variable, and the number before the variable is the coefficient. So we say, okay, let's go back to this. We say divide both sides by the coefficient of x. So now you understand this very grammar now, what it means, coefficient. So, and the coefficient here is 2. That is the number before the variable is 2. So it simply means 2x divided by 2 equals to 24 divided by 2. So this is 2 here, cancel 2 here, 2 here, 1, 2 here, 2. So that means your x is equals to 12. So that is what you're being asked to solve for here. So I hope you understand this. So let's take one more question before we go into the law of logarithm. It's just the brother of one another, that is indices and logarithm. So we have 4, 3n multiplied by 4 raised to power minus 1 divided by 4 raised to power 3 divided by 4 raised to power 3. So how do we go about this? We have been asked to just simplify this, not look for anything, just simplify. And what it simply means by simplify is that make it something simple, make it compatible. So therefore, you can see, look, the first thing I ask you to always check out for is that are they of the same base before you actually try to use the law of logarithm on them. Are they of the same base? Look at this, they are all of the same base. And how many laws are combined here? One, that's multiplication, division, and inverse. Multiplication, division, and inverse. So now, according to law of multiplication, says that when you have if you have a raised to power x multiplied by a raised to power y, what do you say? A raised to power x plus y. If you have a raised to power x divided by a raised to power y is the same thing as a raised to power x minus y. If you have a raised to power minus 1 is the same thing as 1 all over a. Let's say minus n is the same thing as a raised to power n. But we have to check something also using our board mass. Using our board mass, division comes before multiplication. So just apply all this law together in here. So what we do is that we just say, okay, this is good, it's of the same base. So this is the same thing as 4 raised to power 3n plus minus 1. Now everything you have here, now because it's divided by 3 minus 3. It's as simple as that. Minus 3. So n plus minus 1 minus 3. Because this is division, this is multiplication. Straightforward. So this is 4 3n. Now plus this bracket here means division. Remember, board mass. Plus multiplied by minus. Now take note of this. Minus multiplied by minus, negative by negative equals to plus, positive, positive, negative, positive, negative, negative. So now positive, positive is positive. So because of this bracket, that means this is minus 1, minus 3. So now minus 1, minus 3, you are deficit of 1, also another deficit of 3. That means minus 1 minus 3 means minus 4 because you already are deficit of 1 and deficit of 3. So that means you have 4 because this one does not have any variable at the back. It's just the variable here is 0. So that means you have 3n minus 4. So this is the simplified equation of this very equation. All right, let me give you some assignments on this now. Let's consider some assignments. Let's consider some assignments before. So here are some of the assignments I will want you to try your hands on. You have 2 raised to power 4 into n divided by 2 raised to power 3. Number 2, 25 raised to power 7.5 multiplied by 5 raised to power 2.5 divided by 125 of the power of 1.5 equals to 5m. What you're solving for here is m. Then here you have a raised to power b x minus 1 equals to b all over a x minus 3. And this value 1, 3 cube root of 27x cube and y 9. Now, quickly, I need what we call the combining indices. Combining indices, index law. It's simple, just to give you an idea into this. And also, before we move into that, what about if you have that should be law 10, okay, law 9. What if you have an indices and an indices of the same power of different base? What do you do? Let's take, for instance, if you have a raised to power n divided by b raised to power n. So what do you do? What do you do? Now look at this. The base are not the same thing. The base are not the same thing, but the power are the same. So what do? All you need to do is just say A all over B. But now the power is the same thing. Let's look at this from here. You say A raised to power n all over B raised to power n. But the power are the same thing. The power are the same thing, but the bases are not the same thing. So all you do, just bring this into this, then put the power as the same thing. All right. Then now combining, let's go to this to give you an insight into how you solve this. Combining index laws. That is combining the indices law. So what if you have questions like this? If you have 4a squared b cube divided by is a a cube, okay, divided by b squared. We have something like this. You can see we still have the base here. Now note something. You must have something that is actually bringing them together. Can you still apply laws of indices? Yes, you can. Yes, you can. So what you do here is you have your remember the law that says that if you have of the same base, a raised to power x divided by a raised to power y is the same thing as a raised to power x minus y. So but now this time around, since there is multiplication between all these variables and the coefficient, so the very thing you are using to actually solve this very question, this very b here, this base will only be affecting the base that you have here. So it's not going to be affecting a. All right. So what you have, you just say, okay, the solution to this, what you have, you just say, okay, 4a squared. Now you bring this one out, b cube divided by b squared. Because if we try to express this simply here, if we try to express this, so what you have in the simple math, you just say, okay, 4a squared b cube divided by b squared. The simple math just means divide this one by this. That's what you have. So now, but we're trying to solve it in an indices way. So you just say, okay, 4a squared b cube be this. So this is the same thing. Now you follow this law, the same law that I wrote the other time, divided by a y, which is ax minus y. So we just, okay, this is 4a squared raised to power 2, 4a raised to power 2, that would be b cube minus b raised to power 3 minus 2. B raised to power 3 minus 2. So this is 4 a raised to power 2. This is 1, b raised to power 1. And anything raised to power 1, and then this is b raised to power 1 is the same thing as b. So this is equals to 4a raised to power 2 b. All right. So that's an insight on how you solve this. That's an insight on how you solve this. All right. So if you can drop your comments below if you have additional question as regards this. Thank you very much.
Join us and subscribe on all our social media handles. Subscribe to our YouTube channels, Facebook, Instagram, Twitter, TikTok, and all our social media handles. God bless you.